In today's video, we are going to connect something that you learned about with graphing lines, specifically slope, and how we can use that to talk about parallel and perpendicular lines and comparing them. So that means we need to go back real quick and review slope. So slope, we have a formula. You probably heard of it as rise over run, which is an easy way to remember kind of which way you're counting on the graph. But you may have some instances where the points you're given maybe don't fit on a graph, they're large. So we still need to have our formula to be able to find those. So our formula is m, little m, so we don't confuse it with our midpoint formula that we used last unit, equals y2 minus y1 over x2 minus x1. And we can't have x1 and x2 being equal. Reason being, if you have those two numbers in the denominator equal to each other and you subtract, well, what happens when you subtract something from itself? You get out 0 as your answer. And are you allowed to divide by 0? We're actually going to see this happen in a problem, so we'll know what to do when this pops up. So example 1, let's just see what happens when we start plugging our values in. So we want to find the slopes of lines P and Q. So let's do these two separately. So our first one, let's look at, let's change to blue. So let's look at line P first. So we need 2 points that line P goes through. And these are already labeled for us. So line P, they're showing us that that goes through the points 1, 2, and -2, -2. So it's not a bad idea, kind of like when we were doing distance formula. Go ahead and copy down your points and then label them with your x1, y1. So x1, y1, x2, y2. And then we can just plug them in our formula. So our slope is equal to our y2, -2, minus y1, which is our 2, all divided by x2 minus x1. So numerator, -2 minus 2 gives us a -4. -2 minus 1 gives us a -3. But if we divide a negative by negative, our answer really comes out positive. So this is really 4/3. So that's our slope of line P. So then let's look for the slope of line Q. So for line Q, they gave us the points -2, 2, and 2, 0. So -2, 2, and 2, 0. Label these out with your x1, y1, x2, y2, and then plug them in the formula. So our slope is equal to y2 minus y1 over x2 minus x1. Again, you know me, I like to write all my negatives and minuses, and then I can simplify it in the second step. 0 minus 2 gives me a -2. 2 minus -2 is really plus a +2, so we have -2/4. But can't we simplify that? Yeah, 2 and 4 have a common factor of 2, so I can really write that as -1/2. So that's the slope of line Q. We can do exactly the same thing with horizontal and vertical lines if you don't remember what the properties of those lines are. So let's do that in example 2. So example 2, find the slopes of line R and S. And again, we're given some points. So let's start with line R. So line R, again, it's kind of small, but there's our R. So we're looking at points A and B. So our points are -3, 2, and 2, 2. And it doesn't really matter what order I'm writing them in. It's just as long as I have an order to use in my formula, that's what I'm looking for. So again, x1, y1, x2, y2. So plug in our formula. So we've got y2 minus y1 over x2 minus x1. And so then we have the expression 2 minus 2, wait a second, that's 0. 2 minus negative is really plus a positive, so that's 4. But wait a second, 0 divided by 4, what's 0 divided by anything? Yeah, if you're not sure, plug it in the calculator and you get out the answer 0. So hopefully you're remembering a little bit of that from Algebra 1. Your slope of line R equals 0 because he is a horizontal line. Any horizontal line is always going to have a slope of 0. And technically, if you remember, you probably used the trick Hoy-Vux when you were graphing lines before. Horizontal lines have a 0 slope and they always look like y equals. So actually the equation of this line would be y equals 2 because it goes through 2 on the y-axis. Okay, so wait a second. If that's a horizontal line and a slope was 0, can you remember what a slope of a vertical line is? Well, let's check it out. So line S, again, our 2 points, we have points D and C. So we have 1, 1 and 1, -3. Label your values and plug in your formula. So y2 is -3 minus y1, x2 minus x1. So -3 minus 1 gives us a -4, but what's 1 minus 1? We have a 0, and unfortunately you cannot divide by 0. If you plug this in any calculator, you're either going to get an error message or a message that says undefined. So this is slope of S is undefined. I like to think of it as I can't walk across that line. I can walk across any other line. I can walk uphill, I can walk downhill, I can walk on a flat surface, but I can't walk directly up. So that's how I remember undefined slope. So also too, your vertical lines, that's this piece, the vux. Vertical lines have an undefined slope and they have an x equals equation. This one goes through x equals 1. So his line equation would just be x equals 1. Alrighty, so we can also use this for graphing lines as well. So don't forget you've got this y equals mx plus b format that you did most of your graphing in, and you're going to see that popping up again today. So let's write equations and graph them out. So example 3, we have a line with slope of 2/3 and a y-intercept 3. So that means our slope 2/3, we're going to put that in the m spot with our equation. Our y-intercept, that goes in the b. So our equation is y equals 2/3 x plus 3. And so to graph this out, again, remember from Algebra 1, you actually want to place your y-intercept first and then count out your slope. So placing my y-intercept at 3, I'm going to go up 3 on the y-axis. And then counting out my slope, this is where that whole rise over run comes into play. So rise over run means I'm going to rise 2, I'm going to go up 2 units. Run 3, I'm going to go in the positive direction 3 units. Excuse me. And I plot a point. Now, I just barely have enough room that I could do that again, but I could also count out in the other direction. So if I just reverse both of them, go down 2, backwards 3, there's my line. So that's my line number 3. Okay, so let's do that again. Example number 4. So in example 4, line with slope of 3 and y-intercept of -5. So y equals 3x minus 5. Now we have a problem here. We don't have a fraction for our slope. So do you remember how do you turn a number, any number, into a fraction or a rational number? Now just rewrite it over 1. Excuse me, that's a -5. So then now I have my info to count out rise over run. I started with a y-intercept of -5, so count down 5 units. And then rise 3, run 1. So up 3, over 1. Up 3, forward 1. Connect your dots. And notice too, I'm writing 3 points down to draw my line because I want to be as exact as possible. If I only draw 2 points and one of them's incorrect, my whole line is incorrect. So always be careful with that. Go ahead and pause the video then and try graphing out 5 and 6. Okay, let's see how you did. So I'm going to do my next one purple. So let's see here, slope of -3/2 and y-intercept of -3. So my equation is y equals -3/2 x minus 3. So I need to go to my -3 y value. Negative slope means I'm going to count down 3 and forward 2. So down 3, forward 2. Again, not enough room to do another point in that same direction, so completely reverse your orders. So instead of down, go up 3. Instead of forward, go backwards 3. There's my line for number 5. And notice as I'm graphing, I'm labeling what I have because, you know, if I'm having to label multiple things on the same graph, I want to know what's what without having to totally redo my problem. Okay, so then number 6, let me do a different color. Let's see, I think I can switch over to green. There we go. Awesome. So line with slope -1/3 and y-intercept 0. So y equals -1/3 x plus 0. Well, wait a second. Does it make sense to actually write plus 0? Because what does adding 0 do to anything? Absolutely nothing. So I could write this as just -1/3 x. I have a y-intercept of 0, which means I'm starting right at the origin. And a slope of -1/3 means down 1, forward 3. Down 1, forward 3. So do you notice anything about some of these problems? Compare your purple and your blue line. They're definitely not parallel, but what else could you call them? And what about your red and your green line? Well, those guys also, they're not parallel, but I could definitely see those as perpendicular. So check out what your slopes were between those problems. So we had a -2/3 and -3/2 between our 3 and 5 equations. So those looked like they were perpendicular to each other, and my fractions, my slopes, look like they were flipped and the sign changed. What about on problems 4 and 6? So wait a second. On those, we had a slope of 3/1 or 3, and we had a slope of -1/3. Hey, same thing was happening. They're reversed, and we changed the sign. So actually, if we're looking for whether or not sign or lines are perpendicular, we can look for, hey, do those slopes look like they are negative reciprocals from each other? If lines are parallel, if they're going in tandem, well, their slopes would have to be exactly the same. So we can actually analyze our graphs, even just knowing a couple points on those lines. So let's check that out. So when we're looking at parallel versus perpendicular slopes, if we have parallel lines, they should have the same slope. And if they're perpendicular, they should have opposite reciprocals as their slopes. So let's try a few of these out. So let's find the slope of line AB and line CD. So for this first one, again, slope is subtract your y's, subtract your x's. So subtract my y's, I have a 6 - 3 over 2 minus -2. And again, if you need to label your x1, y1, go for it. Simplify it out. 6 - 3 is 3. 2 minus a -2 is actually +4. Our slope on CD, let's see, again, I'm using, this is my first point, this is my second point. If you want a quicker way to label, that's one way to do it. So again, y's, I have 3 - 0. X's, I have 3 minus -1. That takes me to a 3 over 4. Well, wait a second. Slope of AB is 3/4, and so is the slope of CD. So if they're the same, then the lines must be parallel. Okay, go ahead, pause the video and try out problems 8 and 9 and see what happens. Okay, let's see what you came up with. Okay. So same thing, I'm looking for line AB and line CD. So +2 minus a -12 for my y's, -2 minus -9 for my x's. So that gives me a 14 over 7, otherwise known as a 2 or 2 over 1. I'm going to leave it as 2 over 1 because it's a little easier to compare with my slopes. Same thing with CD. Again, first point, second point, if that helps you label. So y's are -2 minus 6, x's are -5 minus 1. In our numerator, we have a -8. In our denominator, we have a -6. And so if I go through and simplify that, well, negative divided by negative is positive. And 8 and 6, they have a common 2. So that means I could simplify that out to 4/3. So slope of AB was 2/1. Slope of CD is 4/3. Yeah. They're not equal. They're not negative reciprocals or opposite reciprocals, so they don't have any relationship. So number 9, let's see what happened. So I'm going to go back to purple, actually. Little more contrast, easier to pull up on these pages. Okay, AB again, first point, second point. Subtract your y's, so 4 minus 3. Subtract your x's, -1 minus 2. So we're looking at a 1 over -3. I like to write my negatives out in front of my fraction. It doesn't really matter, but for comparison purposes, it might help. Okay, first point, second point. Okay, 6 minus 3 over -4 minus 5. So we have a 3 over -9. Simplify that out. We have -4. Ooh, what did I do? Anyone catch my typo? -4 minus a -5. I left off my negative sign. So that really becomes plus a positive. So we really just have 1 in the denominator. So comparing our slopes, we have a -1/3 and we have a 3/1. Hey, those are opposite reciprocals, so these are perpendicular. Hey, if you need to, pause the video, take a break, but let's look at our last section. Okay. So in number 10, we need to look at our equations, figure out what our slope is, and then make our decision whether or not our lines are parallel, perpendicular, or neither. Now, these equations, they're already in that y equals mx plus b, our slope-intercept form. So all we need to do is identify our slopes. So we have a slope of 4/7 on our first line and a slope of -7/4 on our second. So these are opposite signs. They look like they're reciprocal. So that means the lines have to be perpendicular. In number 11, we don't have them in our slope-intercept form. So we actually need to put those into slope-intercept form, and we're going to do this by solving for y. Now in our first equation, that's pretty straightforward. So first equation, all we have to do is divide all terms by 3. So that leaves us with y equals 2/3 x plus 14/3. And again, I'm not so worried about that intercept being a fraction because all we're concerned about is the slope. And our slope on this one is 2/3. So then let's do the similar thing with our second equation. We need to get the y by itself, which means we want to move everything else away from that. Let's subtract a 4x first from both sides. So -6y equals -4x minus 24. And I like to put the term in front because that most closely models that y equals mx plus b. And then we need to go through and actually divide every single term by that -6 to get that y by itself. So that leaves us with y equals, well, wait a second, -4 divided by -6. I know the negatives will cancel out, divide out to be a positive. But then 4/6 also simplifies to 2/3. And then -24 divided by -6 gives us a +4. And so his slope, wait a second, is also 2/3. If they have the same slope, that means they must be parallel. Alrighty, and then in number 12, instead of line equations, I just gave you the lines. Now we have some points marked. We could go through and find the slope of those coordinates, but if we know these points and they're accessible on the graph, let's just count out our slope. So we have to make sure that we're counting between points that are actually on the grid line to give us an accurate slope. So on our top line, the only points I see are the ones marked A and B. Nothing else goes perfectly through the grid. And so we have to rise 1 and run 1, 2, 3, 4. I always count spaces when I'm looking at these. So the slope of this line is going to give us rise 1, run 4, or 1/4. On our CD line, again, I don't see any other points that go exactly through the grid other than C and D. And to get between those, I have to rise 1 and run 1, 2, 3, 4, 5. So his slope is 1/5. Now, the slopes are not the same, but they're not negative or opposite reciprocals either. So unfortunately, that means these guys just have no relationship. You want to be careful because there may be some problems where even if you graph out your lines, they look so close to parallel. Now this one you could tell it was a little off, but it might be a little close for some people to tell. So always count out your slope, always find points to either calculate your slope or count it out to make sure you are using specific numbers and not just eyeballing it. Okay, our last two examples are, well, what if we had to use this information for something? And so you will definitely have a point like or a problem like this on your test and potentially if you have to take the SOL. So our first problem says, and actually both of the problems directions for both of them say use the graph given with line AB and point P. So we have our line AB goes through those 2 points and then this random point P sitting at 2, -2. Okay, so our first problem, number 13, graph the line parallel to line AB that passes through point P. So before I do anything else, if I want a parallel line, I'm probably going to need to know what my slope is so I can graph that out. So my slope of AB, well, let's go ahead and figure that out. So our point A is at -2, -2. Our point B is at 2, 0. So that means our slope is going to be subtract our y's, so 0 minus a -2, x's 2 minus -2, and simplify that out. So we have a 2 divided by 4, otherwise known as 1/2 if we reduce it. Okay, so I'm going to go back and reread problem number 13. So it says graph a line parallel to line AB that passes through point P. So if it passes through point P, that's actually where I'm going to start. I know my slope has to be 1/2 if I'm doing a parallel line. So starting at P, a slope of 1/2 means I'm going to rise 1 and run 2. Now, again, when I'm graphing a line, I don't want to stop at just 2 points. So let's just keep going in the opposite direction until we have several points so we can draw a nice straight line. So instead of rise 1, forward 2, I need to fall 1, go backwards 2. And keep going until you run out of points. I can just barely fit it on the end of the graph. Again, the more points you draw, if you're doing this out by hand, which I would highly, highly suggest, the easier it is to draw a straight line. And especially too, if you ever end up drawing anything on the screen and you're trying to use a mouse, again, if you have your points plotted, even if your line isn't perfect, then I'll still be able to know exactly where your line was supposed to go through. Okay, the last part of question 3 says list 3 points on your new line. Well, we just drew a whole bunch. So let's just list out the points and then we'll circle 3 of them. So starting on the left, we had one point at -4, -5. We had a point at -2, -4. We had a point at 0, -3, and we had another point past P. So we're not supposed to use P at 4, -1. So they wanted 3 points and just, okay, there's 3 of them. You could use any 3 of those points to make that list. Alrighty, so last question, number 14. Read through, what's the only thing different? Okay, graph the line perpendicular. So that means if we started out with a slope of 1/2, what should our perpendicular slope be? So that means we need a slope of -2/1 for this one. Still start at point P and then count it out. So fall 2, forward 1. We ran out of space, we can't go any further, so complete opposite direction. So rise 2, backwards 1, rise 2, backwards 1, rise 2, backwards 1. And as I'm drawing this in, again, it looks like it is perfectly perpendicular to that original line that we had. All we need to do is list our points. So again, starting from the left, I had a -1, 4, I had a 0, 2, I had a 1, 0, excluding point P. because we were already given that. And then we have 3, -4. List 3 points, so just pick 3 of your points. All righty. As always, please, please, please let me know if you have any questions whatsoever. I know we're definitely going back pretty far with this graphing piece from Algebra 1. But don't forget, you can always rewatch, rewind, watch different chunks of the video, whatever you need to, and ask me questions if you have any about this material. See you later.